we are going to go through an introduction to systems of equations. Systems of equations. The difference now when we talk about a system of equations is we might have, instead of just one equation, two of them. So if you have two equations, we're going to have always two variables, or if there's three equations, we need to have three variables. So with this, the solution is going to be something like x, y, like a point. So an x and a y, and it needs to, that makes both or all equations true. Both or all equations true. So it needs to work for, if it's two equations, it needs to work for both of them, or three, it needs to work for all three of them. So what I'm talking about is, let's look at this as an example. X minus y equals 3 is my first equation, and 2x minus 3y equals 5 is my second equation. So if we're asked, is 5-2 a solution? Is 5-2 a solution? So if 5-2 were to be a solution, when I plug in 5 for x, 2 for y, it would make both equations balance out and equal out. So let's check this out. So the first equation, x minus y, so 5 minus 2 equals 3. 5 minus 2 is 3. 3 equals 3, checks out. Then the next one, 2 times 5 minus 3, oops, not 2, minus 3y, so 3 times 2 should equal 5. So let's see if that checks out. 10 minus 6, is that 5? 10 minus 6 is 4. No, 4 does not equal 5. So this means that 5-2 is not a solution. 5-2 is not a solution to that system. So even though it worked for the first equation, it didn't for the second, so it's not a solution. Now let's check out 4-1. Is 4-1 a solution? Is 4-1 a solution? So if I plug 4-1 into the first equation, 4 minus 1, is that 3? 3 equals 3. Yes, that checks out. Then 2 times 4 minus 3 times 1, is that 5? 8 minus 3. 8 minus 3 is 5. Yes, that is true. So since 4-1 worked in both equations when I plugged in the x and the y, then 4-1 is a solution. It's actually the only solution